day everyone. This time we will going to discuss about lesson 8 of chapter 3, which is actually the last lesson in this chapter. So the last lesson is about point estimate of the population proportion. Okay, so this is also a continuation of our lesson of our discussion from lesson 7 of the same chapter. But this time we will going to have the estimation of population proportion. First thing is that in order to understand this part, we need to know, or we need to understand first what is the proportion. So for example, many surveys involve categorical data resulting to estimations of proportion of people. So when we say proportion, it is also telling us the fractional part or the percentage part, okay, or objects having a specific characteristic. These surveys include research questionnaires answerable by yes or no, okay, the names of people or objects, and many more. Example of these surveys are election polling and customer preferences. Okay, so now there is also a point estimation when we are dealing with population proportion. So how are we going to compute for the point estimate, okay, or point estimation? Okay, how are we going to do the process of taking our point estimate? So again, the estimate for population proportion, now it is given by the symbol P and having the formula, which is P is equal to X over capital letter N, whereas P represent your population proportion and your X represent your number of persons or object possessing a certain characteristic of interest in the population. So take into consideration the two formulas here. Here we have the P hat is equal to small letter x over small letter n. Okay, take note that on the first formula, we are dealing with the population proportion. On the second formula, we are dealing with sample proportion. Okay, again, always remember the formula that we are having here. As you can see, your sample proportion is represented by the P hat, that is the letter P with a hat on it. And then the capital letter X, which represents the entire population or the entire number of population, represents your capital letter X, while your capital letter N represents how many is the population. Okay, but the small letter n, as what we have, if we were going to recall what it represent the sample size. Okay, so please take note of those representation that we are often using. Okay, so now we have here, let's have the following. So when a sample size n is sufficiently large, okay, that is then n times p, which is your sample size times your population proportion, is greater than 5, and n times p times 1 minus p, again p represents your population, is still greater than 5. So where p is the unknown population proportion, not expected to be close to 0 or 1. Okay, not expected to be close to 0 or 1. Okay, but the values will going to follow in between. The sampling distribution of P hat is approximately normally distributed by the central limit theorem, with mean is equal to population mean is equals to population proportion, this one, and variance is determines by the Q is equals to 1 minus population proportion. That's your population, or that's your population proportion variance. Okay, so the standard error of the population proportion is which is represented by p hat. Okay, take note. Okay, this is your p hat. Okay, it's given by, okay, this is your sigma sub p hat is equals to or equal to the square root of p hat times q hat over n. So if the population proportion p and q are unknown, you may estimate them by using the sample proportions p hat and q hat, where when the sample size n is sufficiently large. Okay, so how are we going to compute for the variance again? Okay, again, the variance is computed by your q, or the variance is represented by q, which is equal to 1 minus p. Okay, so take note, for example, our population said yes, that is represented by your population proportion, which says yes. And if we were going to compute for those who said no, or the population proportion who said no, that is represented by your q. Okay, that same goes with your sample proportion, which is represented by p hat. If p hat is yes, then q hat is no. So again, p hat and q hat are both population proportion. So example, a survey is conducted to determine the opinions of people on the anti-terrorism bill. In a random sample of 200, 126 are not favor of the anti-terrorism bill to become a law. Okay, so take note that p hat is actually the population proportion that is already determined or already given. Estimate the population proportion who are not in favor of the anti-terrorism bill to become a law. And second, compute the standard error of this estimate. Okay, so solution, first we need to determine your given. Okay, take note, we have sample size of 200 and your x, which represents those determined that are not in favor, is given by 126. Okay, so solve for the estimation of the proportion of the people who are not in favor, okay, of the anti-terrorism bill to become a law. Okay, always remember that the best estimator for the population proportion, or your p, or that is population proportion represented by p, is given by the sample proportion, which represented by p hat. Okay, so take note that in this part, okay, in this part we will just going to, it is given by p hat is equals to x, which those numbers, determined numbers who are not in favor of the anti-terrorism bill, that is given by your small letter x, and then over your sample size, which is 200. So 126 divided by 200, your population proportion is given by 0.63. These are the what we called who are in favor of, who are not in favor of anti-terrorism bill. Okay, so we have for the p hat, which is those who are not in favor, given by 0.63, or what we call 63%. Okay, now if there are people who are not in favor of anti-terrorism bill, that we need to also know what are the sample proportion of those who are in favor of anti-terrorism bill. Okay, so what we're going to do is just simply, we have q hat, we need to know the population, the sample proportion of those who are in favor. So that simply we will going to have your 1 minus p hat. Okay, so substitute, we have 1 minus 0.63, and that is given by 0.37, or 37% are in favor of anti-terrorism bill. Okay, so how would we able to know the number of people which composes 0.37? There are two ways actually. The first one is we will going to multiply 200 by 0.37, and the second one, of course, we will just simply minus 200 minus 126, and that is equal to 4. We have 74 who are in favor. The number of people who are in favor of anti-terrorism bill. Okay, for number 2, how would we able to solve for the standard of error? Okay, so we will going to add a page here. Okay, so the standard error, as we have already determined, for those who are in favor, we have P hat, sample proportion, we have 0.63. Okay, so Q hat, those who are in favor, we have 0.37. Okay, now we will going to use these values to solve for your standard error, what we call the standard deviation of your population proportion. So we have here sigma sub P hat, okay, square root of P hat times Q hat over sample size. So just simply substitute, of course, here it is. Okay, substitute. P hat is given by 0.63 and your Q hat is given by 0.37, and then your sample size is 200. Okay, so 0.67 times 0.37, 0.63 times 0.37, it is 0.2331 over your sample size, which is 200. Okay, so your standard error for your sample proportion is given by 0.0341 or 3.41%. Okay, so if there is what we call the point estimation, we have also the interval estimation, which we also have in our point estimate and interval estimate. Okay, so if population mean has a point estimate and an interval estimate, population proportion has also an interval estimate, point estimate and an interval estimate. Okay, for the interval estimation for the population proportion, we have the following. Okay, take note that we are using here the central limit theorem, whereas we are always assuming that our sample size or sample proportion is actually large enough. Okay, so in a large sample with known sample, okay, we have n times p hat, and q times n times q hat should be greater than 5. Okay, so a times 1 minus alpha times 100% is what we call the confidence interval for the population proportion P. So that is given by the formula here. I know you are already familiar with this formula also, because we have already discussed interval estimate with your population mean. Okay, so as you can see here, we have, okay, P hat minus your standard at your E, or what we call your margin of error, okay, times your standard error, which is P hat times Q hat over N, that is less than P. which is your population proportion, then that is also less than of your p hat. Let me erase that one. Okay, p hat. Okay, why is it not writing down? So we have here the p hat. Okay. Plus z sub alpha over 2. Okay, p hat q hat over n. Okay, so again, this is your margin of error, this part. Okay, the z sub alpha over 2 times p times the square root of p hat times q hat over n. Okay, so and then take note that your this part is your what we call standard error. Okay, so this is also the what we call your error or your margin of error. And take note that margin of error is actually different from your standard error. So this part is what we call your standard error. Okay, again, E is actually equal or determined by z sub alpha over 2 times your p hat q hat over n, while your standard error that is determined by your sigma sub p hat is given by your p hat q hat over n. Okay, this simply show that your margin of error is composed of your z sub alpha over 2. Your this determines by your z. Okay, it cannot be written down. Okay, that is your z sub alpha over 2. Let me have that one. Okay, and your standard error of your p hat. Okay, standard error of your. Okay, now let's continue. Okay, so to simplify this formula above, we have the following. Okay, so this, if we were going to simplify this part, we have p hat minus your margin of error, okay, which is less than your population proportion, and that population proportion is actually less than your p hat plus margin of error. Okay, so example, a certain shipping company conducted a survey on the passenger satisfaction with their service. The survey showed that 182 of 250 passengers are satisfied with their service. What is the best point estimate for the true proportion of passengers that is satisfied with the company's service? Okay, second, construct a 95% confidence interval for the proportion of passengers that is satisfied with the company's service. And third, if less than 50% of the passengers are satisfied with their service, the company is planning to create a plan to serve a passenger better. Is there a need to create a plan to serve the passenger well? Why? Okay, now we will going to go with your given. Okay, take note, given is from our problem, and we have here a sample of 200. Okay, 200 250 passenger. Okay, and out of the 250 passenger, we have 82 of them that are satisfied with the service. Okay, so your X will be your 182, which determines by your satisfied passenger, and your N or your sample size is given by your 250, which is the number of passengers that were being surveyed. Okay, so now the first part is we need to determine the best point estimator. Okay, take note that your sample proportion will be your best point estimator. So as you can see, we have small letter x, which determines by 182, and small letter n, which determines by your sample size, which is 250. So 182, using the formula x over n, we have 182 over 250. So we have 0.73, or 73% of the passengers are satisfied with the service. Okay? Number 2, solving for 95% confidence interval for the proportion of passenger. Okay, so how would we know what are the intervals or the 95% confidence interval which are determines the passenger that is satisfied with the company's service? Okay, so we have, remember that we need to find your Q hat, or those who are unsatisfied. So we have 1 minus P hat, and P hat is 0.73. So 1 minus 0.73, that is 0.27, or 27%, which are not satisfied with the service. Okay, so going back to our formula, okay, so we have P hat, which is 0.73. Okay, take note, we will going to use this formula, and we have already shown that formula earlier. Okay, now the easiest way to solve for this one is first to determine your margin of error. Okay, to determine your margin of error, we need to also first determine your standard error, which is given by your sigma P hat. Okay, and that is square root of P hat times Q hat over M. Okay, this is the other way on how you're going to solve for this one. Okay, and that is given by 0.73 times 0.27 over 250. Okay, and if we were going to compute this one, we have the following value, that is given by 0.0281. Okay, now in order for us to solve for the A, or your margin of errors, we have the following formula. E is equal to Z sub alpha times your QP hat. Okay, so take note that since it is 95% confidence interval, we will going to use your 1.96. Okay, I already given you the values for this one from the last lesson, which is your lesson 7. And again, 95% is given by your 1.96 Z sub alpha over 2. Okay, so remember that your alpha is 0.05, and that is divided by 2. Again, 0.05 came from 1 your 0.05, this one is taken from 1 minus 0.95, and your 0.95 is already given, which is your 95 confidence interval, and that's 0.05. Okay, so divided by 2, that is where 0.025 came from. Okay, so going back, okay, so we have already for your alpha, we have z sub alpha, we have 1.90. Okay, we have the formula. Okay, 1.96, sorry for that, times your 0.0281. Okay, and that is 0. Your E is given by your 0.0051. Okay, so using that, we have now your E. Okay, so that only means your P hat minus E, which is less than your population proportion, and that is your population proportion is also less than your P hat plus E. Okay, we will just going to use all those solvings that we have. So P is equal to 0.73 minus 0.0551, which is actually less than your population proportion. Take note that your population proportion here is unknown, okay? And that is still 0.73 plus 0. Let us correct that one first. Okay, 0.73 minus 0.0551. Okay, so we have the interval, which is 0.6749, which is your lower limit, and that is less than your population proportion, and your upper limit is 0.78. Okay, so this is your lower limit, and this is your upper limit. Okay, so if we will going to write it down, we have here the interval, which is 0.6749 until 0.7851. Okay, so take note that we are going to determine the passenger that is satisfied with given your 95% confident interval. So you are 95% confident that that the passenger that is satisfied with company service is between 0.6749 or 67.49% to 0.7851, or what we call 78.51%. Okay, so the third one, since 50% is not contained in the 95% confidence interval, why can we say that? Because we're basing that in our interval here. Okay, that we have computed for number 2. So, as you can see, our interval of those satisfied customers or satisfied passengers ranges from 67.49% to 78.51%. Okay, and 50% is actually not included in that. We could say that the true proportion of passenger that is satisfied with the company's service is significantly different from 50%. Okay, so again, because we're looking if it is not significantly different, or if there is no significant difference. But this time, since 50% is not included in our proportion interval, because again, that is below 67.49%. Okay, so there is no need to create a plan for the betterment of company service, since it is not it is more than your 50%, which we are looking for to check if there is need for betterment for the company. Okay, now take note, in our lesson 7 we also discuss about sample size determination. That's the second one, because the first one we have already discussed your sample size determination using Sloven's formula. This time we will going to know your sample size determination using your proportion. Okay, now take note of our formula here. Okay, so on our lesson 7, we also compute for your sample determination using your margin of error. Now, as you can see, we have margin of error is equal to z sub alpha over 2 times square root of p hat q hat over n. What we are going to do is just simply square it. Okay, if we were going to square it in both sides. Okay, so square this one. Of course, we need to square this one. What's the purpose of that? To remove our radical sign. So this one will be a whole 1, and then this will be square since it should be distributed, and then your e will be squared also. Okay, so the next step with that is transposition. So we will going to move this one to this part. Okay, by simply let me show you that one on the second stage. Okay, so we have e squared is equals to z sub alpha over 2 squared, and then p hat q hat over n. Now, our main goal here is we need to move this n to the other side. So what we're going to do is just simply multiply by n, also multiply this whole, multiply by n. So we will going to cancel this one, and we have here e squared times n. Okay, we'll move that one first. We cannot move it already. Times n, because we also multiply this to n. So times n is equal to z sub alpha over 2 squared. Okay, p hat times p hat times q hat. Now, since we need to find your sample size, which is determined by n, so we have n, we will going to divide it to e over 2. Same goes with this one, e over 2. Okay, so cancel out. So we have the remaining, we have the n. N is equal to z sub alpha over 2 squared times p hat times q hat over e squared. Okay, and that is how we what is the formula for your sample size determination. Okay, so let's have an example for that one. Okay, so we have here a market research survey will be conducted on the consumer's preference of cell phone brand. How many sample is needed if the maximum error must not exceed 3%? Okay, maximum error or your margin of error. That is another term for your margin of error. Okay, at 90% confidence interval and has a sample proportion of 0.48. Okay, sample proportion is 0.48. So we can say that we have the sample proportion, which is your p hat, and that is given by 0.48. Your E, or your margin of error, or another term for that is the maximum error or minimum error. Okay, so that is given by 3. And 3%, or what we call, or 0.03. Okay, and 90% confidence interval. Take note that your Z sub alpha will depend on that. So that is given by, determines by your alpha. Okay, 90% determines your alpha. So this also follows that your alpha is given by 1 minus 0.90, and that is 0.10. And Z sub alpha over 2 is given by Z 0.10 over 2, and that is Z sub alpha is 0.05. And the value of that C sub alpha, remove that 0.05, is given by, okay, over 2 is given by 1.645. Okay, so we have now the given. Okay, next we will going to use this given to our formula. Okay, so to determine your sample, we will going to use the formula here. Okay, so N is equal to Z sub alpha over 2 squared P hat Q hat over E sub 2. I take note, before we forgot, we are missing one given here. That is your Q hat, and that is determined by 1 minus P hat, and 1 minus 0.48 is equal to 0.52. Okay, so now we will going to apply whatever we have here, or what are the given to our next slide here. Okay, so now we already determine what are Z sub alpha over 2, and as you can see here in our formula, so again, take note that for our given, so we have C sub alpha over 2, which is your, let us erase that one. Your Z sub alpha over 2 is given by your C sub alpha over 2, or C sub 0.05. And take note that C sub 0.05 is given by 1.645 in our given, that's squared. Your P hat is determined by 0.48, and your Q hat is determined by 0.52. Okay, over your E, which is actually a given of 0.03 squared. And if we were going to compute all of this, using your calculator, we have 751.57. And again, any decimal number determines by automatically plus 1. So that's 751 plus 1. Because of this is automatically plus 1. That is a total of 752. So now your sample size is actually 752. Okay, so thank you everyone and have a blessed day. Goodbye.